Hi, this is Ms. DB, and we are going to go over what are matrices and how to add and subtract them and multiply by a scalar. So first of all, we have to go over what is a matrix. A matrix is just a rectangular array of numbers. So it's a way of recording numbers or data. We name it with a capital letter, and here's some examples of matrices. If you have one of them, it's called a matrix. If you have more than one, it's a matrice. So in matrix A, it's only one row with two entries, 2 and 4. So that's 2 columns. B is 2 rows with 1 column. So the rows go across and the columns go down. The dimensions of a matrix are determined by the number of rows and columns in the matrix. And we would call this M by N, that we use a small x for this by, but we would say by. So we have M rows, N columns. So matrix C here would be a 2 by 2, and we'd write 2x2. D would be a 2 by 3. Every value in the matrix is called an entry. You can find an address of each entry by using the letter of the matrix and then using small subscripted numbers after that would be row and then column. So D21 means in the matrix D, second row, first column. So that would be -2. We can use matrices in order to record real-world data. We can take that data from something like a table or from a description of a problem. When you write it as a matrix, it simplifies what you have. You would only write the numbers. They would just be in rows and columns. So really, if you were going to be working with the data, having it in matrix form would simplify and make it easier to add, subtract, multiply, and so on with that information. Again, we talked about address. In this one, the address of the entry 21 is 16.206. If you are asked to display data in a matrix, remember you only put the numbers. Do not even use the dollar signs. So for A, you would just write the numbers like this. The dimensions, that's very important that you know what the dimensions are. Don't forget, it's always rows by columns. Always has to be rows first. So this would be a 3 by 2. If you have this matrix here, am I able to take a screen? I can. I'm going to take a picture of my matrix so I can put it on the next page. On the next page, we have this information again, but I bet I can't paste into a slideshow though. That's all right. The matrix on the previous page we saw was just 3.95, 5.95, and so on. And now they're asking what would entry P32 be. That's the third row, second column. So that would be third row if we think about this little box here being our matrix. Let me see if I can grab my pen here. Where our brackets would be around just the numbers. So the third row, second column would be right here, 5.25. The address of the entry 5.95, that's up here. So we can see that that's in the first row, second column. Now I have I can just barely see these things down here. There we go. Okay. All right, so you will be asked to do this on your worksheet. You'll be asked to answer some questions about a matrice. Make sure you know that the dimension is always row by column. This one would be 3 by 4. The entry at M32 means row 3, column 2, so that would be the number 11. The entry 0 appears at what 2 addresses? You see that's up here in 2 different spots. One of those spots would be 14, M14, first row, fourth column, and one would be row 2, column 3, so M23. We can add and subtract matrices, and all you have to do in order to add or subtract matrices is add or subtract the corresponding entries. So you would take that Whoa, here we go. 1 plus 5 is equal to 6, and 2 plus 10 equals 12. That's how you get your new matrix. The original matrix dimensions will be the same as your sum or difference. You can only add or subtract matrices if they have the exact same dimensions. So you should check that first before you even try to add or subtract. If they're not the exact same dimensions, they can't be added or subtracted. So if we're going to add matrix W plus matrix Y, first we check if they have the same dimensions. Matrix W is a 2 by 2. Matrix Y is a 2 by 2. Same dimensions, so we can go ahead and add them. So we would add the 3 plus 1 to get that entry. We would add the negative 2 plus 4. We would add 1 plus negative 2, and we would add 0 plus 3. So the corresponding entries go together, and our new matrix then would just be after you do all that adding, and you don't have to write this matrix out, but if it helps you, if your numbers maybe are big or complex, then you could do that. Otherwise, all you need to show for your answer is this. This one is a subtraction, x minus c. We've got a 2 by 3 and a 2 by 3, so we can go ahead and subtract. When you subtract, be careful of the minus a negative. Make sure that you don't make mistakes like on this one when you do 7 minus negative 2. That's really 7 plus 2. So this one, when you subtract each entry with its corresponding entry, you would get the matrix 2, 9, negative 1 for the first row, 4, 1, negative 5 for the second row. Whoops, I clicked on that kind of quick, but X is a 2 by 3 matrix and Y is a 2 by 2. They do not have the same dimensions, so you could not add them, you could not subtract them. You can't work with them when they are not the same dimensions. Well, you can't add or subtract them. All right, we're not going to go over this. I made a separate video on how to make a matrix in Word. There is some equation editors that you can use to make a matrix. Otherwise, you can use the bracket on the keyboard, the square bracket, which is just to the left and above the enter sign. It looks like this, and you could do this around each row if you can't figure out how to make a matrix using the equation editor, or copy and paste the ones that are already there. All right, we can multiply a matrix by a number called a scalar. It's quite simple. You would just, if you wanted to multiply matrix 2, 4, 3, 7 by 3, you just multiply every single entry in the matrix by 3. So you go 3 times 2 is 6, 3 times 4 is 12. It's kind of like the distributive property, except you're using a matrix, and 3 times 7 is 21. So your new matrix would be 6, 12, 9, and 21. We could use this in an application problem, a real-world type of problem where you're looking for a sale price. So we could put these shirt prices in a matrix. It would be 4 by 2, 4 rows by 2 columns. And then in order to find a 10% discount, you would multiply that matrix by the scalar of 0.1. 10% is the same as 0.1. And then to get the new price, you would take the original price minus your percent discount, and that would be your final price. So here's our original matrix, 7.5, 15, and so on. These are the prices. Then again, we would subtract 10% or 0.1 times those prices, which is in red right here. This is how much off of each shirt you would get. And then you would subtract those two numbers and get your final price. This is how much these prices would cost during the sale. You could also just multiply the original prices by 0.9 and then not do all the rest. That'd be like a shortcut. Oh, I have some information here from the last time I tried this video. Okay, in this example, we are trying to evaluate 3 times p minus q. So you would take your p, which is here, and you would multiply every entry by 3, and we get this. 3p is 9, negative 6, 3, 0, 6, negative 3. And then we want to subtract q. But when I go to subtract Q, we have two different dimensions here. We have a 3 by 2, and this is a 2 by 3. 3 by 2, 2 by 3. They don't match, so we cannot finish this. And I could have checked for that at the beginning if I wouldn't have got so excited about doing my scalar multiplication there. So since they do not have the same dimensions, then you cannot subtract. Okay, here we have 3r minus p. So here's r. It's a 3 by 2, and I'm going to multiply it by 3. That's not going to change the dimensions. P is also a 3 by 2, so I should be able to complete this then. Let's check. If I multiply 3 times every entry, I would get, here it is, 3 times 1 is 3, 3 times 4 is 12, 3 times negative 2 is negative 6, 3 times 3 is 9, 3 times 0 is 0, 3 times 4 is 12. And then I have to subtract the matrix P, and I go 3 times 3, or 3 minus 3, now I'm doing subtraction, is 0, 12 minus a negative 2 is 14, and so on. And I get this, and then I'm done after that. So these are not too challenging, really. The properties of equality for matrices, they're not all the exact same ones as for real numbers. Commutative property is, it holds. You can add matrix in either order. The associative property is true if you have all adding. You can either add the first two together and then add the third one, or you could add the last two together and then add the first one. The additive identity, there's a 0 matrix where every entry would be 0. If you add a matrix to its 0 matrix, then you get the same matrix back. The additive inverse is when you add a matrix to the opposite of every entry. So we'd have 5. The opposite of that is negative 5. The opposite of negative 2 is 2. So these two matrices added together gives you the identity matrix, the 0 matrix, 0, 0, 0, 0. These are some problems from your worksheet. So before you get too far on these, check and see if you're actually able to add or subtract them. Like in number 12, we have a 3 by 3, 3 rows by 3 columns, and we're subtracting a 3 by 2. So that's not possible to do that, so you can't, you just write not possible. In the next one, T plus R, they're both 3 by 2 matrices. So we can add, so you would take 4 plus negative 5, and that will be your first entry. And 12 plus 9, that'll be your second entry. And then you'll continue doing that for each of the corresponding entries in the matrices. In number 14, it says 2R. All you have to do is take your matrix R, and you're doing scalar multiplication, so you'll multiply every entry in here by 2. So 2 times 4 is 8. I wrote that already. And then all of the other ones need to be multiplied by 2 as well. In number 15, we're going to use 2R again. So you could take your answer from there and then subtract the matrix for T. And those will be the same dimensions. They'll both be a 3 by 2, so you'll get an answer. All right, so if you have any questions on this, let me know. Otherwise, this worksheet should be pretty straightforward and not too complex. Good luck and enjoy working with matrices, and let me know if you have any questions. Thank you very much.